All right. Hello and welcome to today's webinar, Preparing Students for Industry 4.0 Careers with Arduino PLC Solutions. Thank you for taking time to be here with us today. Just a few housekeeping notes before we jump in. We'll be running a live question and answer session towards the end of the webinar. So please feel free to use the chat feature to pop any questions that you have, and we'll address them when the time comes. Also, if you miss any part of the content today, don't worry. We're going to be sending everyone that registered for the webinar the on-demand recording when it's available. Before we get started, I'd like to share a little introduction on the sponsoring organization of the webinar, Pitsco Education. Pitsco Education is a leader in future-ready learning, fundamentally rooted in STEM. For more than 50 years, we've offered a comprehensive range of scalable, hands-on resources and curriculum. We help educators create learning environments that address all learning styles and help all students find success while solving problems, being creative, articulating ideas, and thinking with their hands. And now we're ready to get started, and I will turn it over to my colleague, Jason from Arduino Education.
Hi, good day, everyone. Thank you so much for being with us. Thank you, Steph, for that awesome introduction to Pitsco. Let me say that Pitsco is one of Arduino's favorite partners because of the local support that they provide. So one of the things I love about Pitsco is they have this really great team throughout the U.S. And so it's fun to work with them because if I have an educator that needs someone in person for something or some support, Pitsco usually can make that happen pretty quick. And so it's fun to work with you from that standpoint. That combination of local support plus the really great technical support that Arduino can provide really makes it great. But I'll give you a little bit of background about myself. I'm Jason Strickland. I lead Arduino education in the Americas region. And prior to joining Arduino, I was a dean for academic affairs and curriculum director in the technical college system of Georgia. And so I know very, very well the world of PLCs and industrial automation and have worked on multiple labs. And so I'm coming in with that mindset of having been in the classroom in the lab before as we start the webinar today. And I'll try to give that kind of perspective from what I've seen as we go forward. I'll be jumping kind of in and out of a slide deck, but also showing you various websites from the Arduino ecosystem that are very helpful as we get started thinking about PLCs. But the Arduino PLC Starter Kit is really designed to enhance hands-on opportunities for industrial automation, but using pro hardware. It's the first product that actually takes our industrial grade hardware and puts it in a student facing educational kit. So this is not a kit that is only for education. This is the same exact PLC that we put in factories all across actually across the globe everywhere. I just came back from a sales trip to Mexico and saw in person where this was installed in Tijuana in the steel case factory there. So we're not talking about just a skill that's a classroom skill. This is a skill that leads to real world jobs and applications, and it's something that will be super useful for your students to walk away with. In a classroom environment, we do have to have a way for students to get some experience. And so there is in the content the simulated factory setting. But I want you to keep in mind that when that simulation is directly applicable to real world hard skills that are in demand in the job market all day, every day. In fact, it's a skill set that really will boost an engineering career, a mechatronics career, a electronics technician career. Just there's such a wide array of where PLCs are useful, and Arduino makes it easy to get started, which is the cool part about it. So this is the PLC student kit. You'll see that that is the actual optic that comes in it in the box, and it is really kind of the plug to the future of industrial automation. We're talking about why did Arduino create this PLC starter kit? Why would we take one of our pro products and throw it into an education kit for students? And honestly, the reason for us is that direct school to career transition, the ability to strengthen the CTE segment and give students hard skills that are directly applicable to a future job is super exciting for us. Kind of the root of Arduino education, our core DNA, is preparing students for jobs and careers and giving them useful skills, and knowing that we have that direct school to career transition is one of the reasons we decided to create this kit. Um, we are really, when we create a product, we actually start back from teachers. We consider teachers to be our end users of any of the kits that we produce in the education space. So this kit is designed to support teachers in areas such as industrial automation, mechatronics, engineering, technology, and other CTE pathways. It's a great fit for career tech programs, STEM academies, technical education tracks, and it allows you to focus on interesting new fields like smart energy systems, manufacturing, sustainable technologies, and information and communications technology. So ICT, there's a lot of different fields where PLCs can be applicable. And I'll show you actually on our website in a bit how you can find all of the real world use cases as well where this PLC is used. But that's what we're trying to support. So we're considering teachers to be our target audience because we want to make it easy for you to deploy this in the classroom. So the key features of this kit is that it is going to give general knowledge about programmable logic controllers with the Opta Micro PLC. It's going to cover specifically the Arduino Opta Wi-Fi, which is our micro PLC, and provide a first hands-on approach to using the Arduino PLC IDE. And this is really important here. I know this is a long number, but this IEC 6131131-3 standard is a system of programming languages that are ladder, function block, structured text, and some others that are part of the industrial automation space. And so what I hear all the time from people that have never used an Arduino PLC kit and they open it up and they tell me, oh, you know what, this looks similar to brand X, or this looks similar to it's because it's an international standard, and so it doesn't really matter which PLC environment you jump into, because they're all following that standard set of languages. The software is going to look similar, and some buttons might be in different places, but the fundamental concepts are pretty much all going to be the same. And so we'll really hone into ladder language, which is the most popular of the IEC 61131-3 standards. We'll also talk about Modbus RS485, which is a communications protocol, really important in the PLC world. And then we'll tie that all in with some industry-ready industrial simulation. So that's kind of where the key features and components of the kit. But that IEC 61131-3 is very important because that's kind of the standard that ties everything together and makes sure that we're covering the content that is really going to help students be successful in the job market. So I recommend this kit for an age range of about 15 years old, so basically high school students and above. We say that we can have up to 3 students per kit in a classroom setup, and the kit is going to contain the Arduino Opta Wi-Fi, simulation boards, cables, and tools. And we have an educational curriculum, which I'll jump into in a minute, that has access to digital lessons and teaching materials and covers up to 20 hours of content. But you can go so much further than that, and I'll show you how to do that as well. The content's going to get you started, but because this is our true professional industrial PLC, you can jump into the wide world of Arduino docs and tutorials as well and really extend the way you use the product with your students and the value that you get out of it. So the Arduino Opta Wi-Fi is our easy-to-use micro PLC. It's got an industrial automation processor in it from STM. It's very easy to start programming it with the PLC IDE. And honestly, the Opta is supposed to be to industrial. If you've ever used our Uno board, the one we're most known for in the maker space, the Uno is the equivalent or the Opta rather, is the equivalent of the Uno in industrial automation. It's going to make things easy to work with, and we'll jump into all of that. So this is the Opta. This is the PLC. This is a standard form factor for a micro PLC. It will fit on a DIN rail, but this is sort of the brains behind the whole thing that really makes industrial automation sing in the background. It's designed to work from 12 to 24 volts. And so you can connect a wider range of industrial switches and sensors and relays to it. And the really neat part about the Arduino Opta is that you can program it with the PLC IDE, or you can use our regular Arduino IDE and use Arduino C. You got a couple of ways you can use it, but it's also got onboard Wi-Fi and Bluetooth, so you can connect it to the cloud, and you can get really interesting dashboards and analytics. And there's lots of use cases already developed to help with that as well. And so we're really trying to speed up the time that it takes for you to jump into. Because we do have to simulate that factory environment I was talking about before we jump into all the course content, the Opta does come with two boards called the Arduino DIN Simulate and the Arduino DIN Celsius. This allows us to have those lessons where students can simulate turning a machine on or off, or they can use the DIN Celsius and simulate temperature controls in a factory environment. And maybe a machine needs to stop when a temperature sensor gets out of spec, right? So we have these boards that are included with it. And we have the wiring. So it comes with the USB cable, the power supply, and the 25 jumper cables. And this part is really important. So first of all, let me say right off the bat, don't be intimidated by the wiring. This kit is a kit that does have to be wired up, but that is an important skill set for students to have. It is so critical that a student knows kind of the fundamentals of how to connect devices into a PLC, because in an industrial environment, you're typically going to be connecting some sort of a sensor or receiving some sort of an input from a machine, and you want to do something with that data or input, right? But the only way to get it is to have that electrical connection connected. And so students need to be able to understand that wiring component as well. And so we have a really good way to walk people through that piece of it. That to me is one of the things that makes this kit a little different. If you have used an industrial PLC trainer in the past, many of them are big boxy units. They come sort of already prefabricated, and students never really touch or see the wiring component of it. They program it and they see the lights and the LEDs and the switches, but the actual connecting of devices to the PLC is not really done. And so that was one of the things we wanted to make sure that in this kit, we gave students at least a base understanding of how to get in there and work with the screwdriver and make a connection and make sure it's electrically good. And so we cover all of that in the content of this kit. And we have a really great video that will walk you through all of it. There's just a close-up of what the DIM Simulate board or the DIM Simulate board looks like. And you can see there that it has connections for 24 volts on the ground. That would be to power it. And then you have the connections 1 through 8, which would actually be the switches that you would wire into the PLC. And of course, the power supply connection is there. So just a really good close-up picture of it. And it really all ties in together with the software. So at this point, I'm going to jump over and show you all a little bit of how that works with Arduino. So we're trying to make this really easy for educators and make it where it's not hard to jump in and start working with PLCs. So like all of our educational kits, we have a course built, and that is the Explore PLC course. So you can access this course for free on our website under arduino.cc/education/courses, or you can go to courses.arduino.cc. It'll take you to the same place. And if you click go to course, it'll bring you to this getting started with PLCs. And this is what makes it easy for educators to jump into PLCs, because actually I get comments a lot, particularly at trade shows, where faculty approach me and they're talking about they only have time for a few hours or a few, maybe a day on PLCs, but they would like to add something to their course about PLCs because they know it's important for this, especially with this push to bring manufacturing back to the United States, right? There's going to be a much more increased demand for this skill set. So the good part is we have this package already put together with the lessons. I'll go to the homepage for the course, and we have the getting started, the first steps. We cover the theory and the DIN projects, and then we have some extra optional projects as well. But the first step is this getting started. And you'll click on the getting started in the course. It'll take you right into the first steps. We cover the introduction, and we'll talk about ladder diagram, function block diagram, structure text, sequential function chart, and instruction list. Those are those IEC 60131-3 languages that we talked about being an important standard. But this course is going to focus on ladder diagram because it's the most intuitive, and it's also the most commonly used in industrial automation. We cover what's included in the kit, and then we actually show step by step how to assemble the kit. So we have the little ingrained into the course, we have these really great walkthroughs and instructables on how to connect the different pieces. We have a really good wiring diagram as well. But we heard from faculty when we were testing this product that, sometimes a wiring diagram just isn't enough. If you want to give this to a group of students and have them be independent, sometimes they need a little bit more than just the diagram. So we jumped over to YouTube and we had our technicians create this really great video. I'm going to show just a piece of it, but we actually show 100% of the steps of how to wire and connect all of the cables from the PLC. And we have the subtitles on the video explaining each step as we do it. So we're connecting the ground to the Opta power supply terminal marked with minus in this case. And so we go through every wire that has to be connected to make this project work. And we literally show step by step how to make those connections. And that's kind of our attempt to take the burden off faculty so you don't have to spend so much time teaching students individually how to do this. You could sort of give them the link to this with the instructions, and they can almost be very self-independent. And one of the things I've noticed is they enjoy doing it. They obviously occasionally make a couple of mistakes, but it's fun for them to go through the process of learning and going back to it. And also the PLC is very resilient, and so it tolerates those mistakes quite well. And it's really good to see students getting involved with a screwdriver and just kind of learning these base steps. I'm going to fast forward a bit. Once we get past the wiring, then we actually walk through connecting all the sensors and the relays. Then we actually go through the software step and we walk through the first lesson all the way through how to install the software, everything that we do. So we have this really great instructable that makes the programming part of it easy. This is what I'm showing on the screen, the YouTube video here is our PLC IDE. It's the programming interface that professionals use to program PLCs, the PLC IDE, and you can use any of those IEC languages with it: ladder, function block, structured text, instruction list. This course is going to focus more on ladder, and it's going to give you but you put in all the variables. And if we can get to the part, but you'll notice in ladder, it's just kind of a diagram, and it almost looks like a ladder. One of the reasons this is used so much in the industrial space is because these diagrams can very closely resemble the same types of diagrams that electrical technicians and other types of engineers use when they design factory spaces. So you can do the programming in a very similar way, and it becomes very easy for someone to look at the ladder diagram and understand immediately, what is going on here. We have heat output 1, heat input 1, heat output 1, heat output LED. So it just makes it very visual to see what we're working with. And that's why ladder is one of the most important things. And so this is just a software download. There is a caveat to ladder programming, and that is it is a bit of a Windows-based world. So this software is designed to work on Microsoft Windows. There are not very many ladder programs that work in the Mac world at the moment, just because the industry as a whole is standardized around Windows. So I did want to mention that one piece of it, that it is a Windows-based programming environment. But we walk through the entire programming. We give you the first steps, and then it makes it very easy. You can start monitoring the values, and everything is there laid out to get started. And so that's one of the things I love about Arduino is the time we put in into designing these environments with the best that we can to make it easy for students and faculty to jump into.
Hey, Jason, we have a really quick question. How about Chromebooks?
Yeah, unfortunately, the PLC IDE does not work on a Chromebook, and I'm not aware of any industrial IDE environment for PLCs that does work on a Chromebook. Now, you can use the Opta on a Chromebook. You just have to program it another way. The Opta is programmable in 2 ways, which makes it pretty unique. Most of the time in the industrial world, we're using ladder diagrams or function block or structured text to program PLCs. That's kind of the old style industrial standard. It is changing a bit in that some of the modern PLCs, including the Opta, support other ways of programming them, in which case the Opta can work with the standard Arduino IDE. So if your students have ever done a program on an Arduino Uno with our regular software on a Chromebook, they could connect the Opta and program it the same way. The only thing is that typically is not what's done in the industry at the moment. It is kind of what they're migrating towards, though, in the future. So we have that flexibility built into the Opta that you can program it both ways. I would still strongly encourage your students to learn and understand ladder, because that's going to give them the best chance for jobs in the current environment the way that it is. But we do have that flexibility to use Arduino C. So that was a great question. Thanks, Nick. Um, Once we get past that getting started piece, that's the part that takes the most time, I think, getting people started and getting into it. We try to make that as easy as possible. Then we cover the theory. So we're going to talk about PLC histories past and present, PLC programming, and we're going to talk about Modbus TCP, which is one of the dominant communications protocols in the PLC industry. Once we do that, we jump into the DIN projects, where we have the DIN Celsius temperature simulator, and we have the inputs, the heating resistors, and then an input simulation and temperature control loop. We try to give a good estimation of the time it's going to take to complete any of these lessons. And I'm going to just click on one. Let's go to the first DIN project lesson. All right. So all of it's going to tell you the lesson, the materials needed. We have these really great diagrams that explain all the different parts of the part that we're working with. And then we give the materials list. And then we're going to talk about the actual type of the project itself, the sensor, what we're doing. And then we're going to walk through the coding and the project. So we give kind of all of what needs to be done. Let me go into the second one. 10 projects. So see, once we explain what the part does, then we go into materials used, and we're going to walk step by step through the IDE. And we have these really great do and don'ts as well. I love that we did that. We try to point out common things we've seen students do in the testing, and then point out, right, what should not be done when we're working in the project. In this case, we're talking that about disconnecting the power source before making any connections. And we walk through the configuration. We have these really great step-by-step instructions for using the PLC IDE. So if you've ever used one of our kits before for the Uno or anything, it's very similar. The only difference is we're using this more graphical software environment called the PLC IDE, which is more common in the professional space. So I really love that we have all of this designed. So there are a couple more things that I want to talk about when it comes to the PLC besides just the content and the curriculum. So we do have the Arduino IDE. And then I've mentioned that you can use the PLC IDE and the IEC 6131-3 languages. That's one of the key things that's important. The industry is kind of migrating towards other ways to program PLCs. And so you can use the regular Arduino IDE or our cloud and program the Opta. Now, in a factory setting, it's actually common that they use both ways with the Opta right now. Many times the Opta has two cores. And so often my electromechanical folks, my technician level factory folks will program the Opta with ladder. But then when they want to network it and connect it to the cloud, the network engineer on that side will use the Arduino IDE, and they'll set up the network connection in the regular Arduino IDE, and you can use both sketches. You can run two at the same time. So that is one thing that makes it pretty unique. So just to point that out, that if students are comfortable in this environment, they can use that as well. So I'm going to jump over, because what I wanted to show as well is what makes me super proud of integrating this product into a classroom space is that it's not just a product that is an educational product. It's our full-on regular industrial IDE. So if you go to our Arduino Pro website, just arduino.cc, click on the Pro tab, and then you can get to applications as always right at the top. And if you go to industrial automation, that is where all of the Opta use cases will live. And so we have these really great use cases already documented for how the Opta is used in industry. For example, one of the most common use cases is tank level monitoring with the Opta. And we have that documented all on our website under our docs pages. We have this great diagram of a tank system, so a big tank and a small tank. And then we have, horizontal level sensors and a pump and a solenoid valve, and we have the Opta and an expansion to allow it to have some more connections. And then you can actually wire all of that up. We give all of the information on how to create this pump and tank level monitoring system. And so this is a use case we would see used in factories all the time. And in this case, we have the code is actually written in the regular Arduino IDE. And so it's one of the ways that it opens it up. We have all these different projects that you can jump into. So one of the things that I really like about the Opta is that it's not just an educational trainer that's sort of tied to working with that training platform and the content. Once you've done those 20 hours of lessons, and if you've gone beyond that or your students are really advanced for some reason and you want to move forward, you can use the Opta in a myriad of different types of scenarios. You could just take the same Opta from the kit and use it in whatever way you would like to. We also have use cases for conveyor belt sorting, packaging and labeling, and all of these are use cases that Arduino has actually implemented with real industrial customers. There's a great video on YouTube, by the way, especially if you're trying to convince an advisory committee of why you might like to use the Opta or to go in that direction. On our YouTube page, we have a great video where Steelcase is a furniture company with plants all around the Americas, in the US and some in Mexico. And they have installed the Opta on these D-stack machines in their factory. These are machines that are not smart today. They're legacy machines. They really just pick up this wood and they stack it, right? That's their role. But if these machines stop, it stops the entire production in the factory. And so they were able to use the Opta, which has a really great price point for an industrial PLC, and to start monitoring that. And here's the video right here on our website where you can get to later. And they explain how using the Opta allowed them to start monitoring these machines remotely. And then if it goes out of spec, they're able to dispatch technicians right to the factory ahead of time and not shut down production. It's kind of one of the most interesting use cases. I love to show these types of videos, not only to like advisory committees and other faculty, but even to students, so that students can understand when they're working through this content that I've not just assigned it to them because I want them to go through and wire this thing and do this work. It actually is a real skill set that leads to a job, a future career that they could have. And I want them to try to imagine themselves in that career as they work through these lessons, because I think that makes it stick a lot more and really helps drive some of the interest behind the way that they do. So the Opta's deployed in all of the 13 Steelcase plants, and it's a really great kind of interesting way to just show some really interesting use cases. So we publish all of those right on our website under the Pro side of the house, and it's always under the Applications tab under Industrial Automation. Another very common use case in industry for the Opta is air compressor and remote condition monitoring. And actually, I didn't know this until I started working as a dean in industrial construction environments. If the air compressor systems go out in a factory, it shuts the production down. It's one of the most critical systems in a factory. But most of the time, there's no central monitoring of the air compressor systems. Many times they buy them at different points as the factory grows. They might be from 2 or 3 different brands. And so there are a number of companies now that are using the Opta to monitor these systems. And then they can get cloud dashboards and analytics. And they can get really great data and monitor them remotely. And then they know when they need to dispatch preventive maintenance. And again, all of that is also right on our website. It's all documented. I think we do a really great job of showing how you can go beyond just the typical classroom. I'm using this Opta because I need to learn this programming skill. And we can go past that into how could I use this Opta if my employer said, you know what, Jason, we have this device, this machine in our factory. It does X. we need to monitor it. How can we make that happen? And students would be prepared to answer that question after going through this course. And I think that's really great that we give them that skill set that can go with them from beyond the classroom into industry with the Opta. The Opta is also very small. It doesn't take up a lot of space. And so it really is kind of useful even for things, for example, I'm starting to see the Opta used in some different types of industrial competitions. And so it's kind of neat to see how it's evolving, how having a PLC in the small form factor allows it to be used sort of beyond just the typical education of just working through the curriculum and the lessons. In the curriculum, we do have some advanced level projects that I just wanted to mention. We do have some projects that require 2 Optas. Um, and so those are sort of extra and projects that use a motor as well. So depending on what you already happen to have, either in your makerspace or you can extend the learning. And so, for example, you can teach students how to do start and stop motor functions with the Opta. And you just need a very small economical 24-volt DC motor for those. And it's a very sort of interesting add-on to add in some extra oomph beyond just the basics of learning how to program and interact with it. So those are there and built for you. And then there are some projects that teach students how to work with 2 Optas and connect them together for different types of inputs and relays as well. So it's really expandable in the types of ways that you can jump through and use it. Then again, if you're looking for even more content about the Opta, things that you could sort of get into and integrate, well, first thing I tell you is you could jump in today on courses.arduino.cc. Right now, all you need is a Google account for free, and you can jump into our courses page and you can look at all of this content. But then you can click on the more Opta tutorials, and that's going to take you to the Arduino docs page, which has the user manual, getting started with RS-45. There are all of these advanced concepts, and we kind of rate them. So notice how this one says getting started with interrupters on Opta. It's a beginner level option. So we could click on this one, and it's going to give us everything we need to know to how to work with interrupters on the Opta. And everything is documented. If I'm looking for something intermediate, then I've got intermediate level. So air compressor remote condition monitoring that we just looked at a minute ago is actually just an intermediate level project. And then if you really want to get into cool things like leading edge things that are on the market today, we actually have edge artificial intelligence motor anomaly detection with the Opta and the Nikola Sense, right? So you can jump into this world of Arduino docs and you can really get interesting with, from edge artificial intelligence using the Nikola and Arduino cloud. So the Opta is a ecosystem that can kind of grow with you as your students and your capabilities grow. I know when I was in the classroom and whenever I onboarded a new educational solution, I probably wasn't jumping into Edge AI in year 1. I was certainly learning the basics and mastering it. But as my capability grew and I gained more confidence, I always wanted to start giving students a little bit more. And that's when I would branch out to these sort of advanced level projects. And the interesting thing was, most of the time I had to design those myself. Arduino has all of this already laid out and on the website. And so it just really makes it, download the code for the project. We have all of that on our docs page. We do a really good job of trying to make things easy. And so there's just the whole world of predictive maintenance is where sort of a lot of these factories are going. And all of that is being done by edge AI algorithms, and the Opta, along with some different types of sensors, can support all of those different types of sort of leading edge use cases. So it's a really powerful little device. It's certainly not just an educational device in any sense of the way. So I'm wondering if we have any questions at this point other than just about the Chromebook. If we do, I'm happy to use the Q&A.
So is this kit for individual students to work on?
Yes, so it can be an individual student or up to 3. I typically like to put students in pairs when they work on the Opta, just because I think it's nice to build those teamwork skills. It helps for resources, but also typically in an industrial environment, you're usually not just a sole practitioner working on one of these. You're typically working as part of some sort of a functional team. So I really love to reinforce those team skills when I'm particularly giving these types of projects.
Are these kits able to be used either quarter after quarter, semester after semester? Are these tools reusable? Um,
Yes, the Opta is very hardy. It's going to last for quite a while in the classroom setting. The only thing that I would recommend that you might want to replace quarter by quarter, and I'll try to show that really quick here, is just the wiring, because you're going to want students to do that wiring and learn that piece of it. And you just need standard jumper wire. It's just a few bucks from any industrial supply house. And so that would be the only piece that you would probably you could save the jumpers and reuse them certainly, but then students don't get the skill set of being able to sort of to strip the wire and to connect it themselves. So that might be the only thing. Everything else, it will last. You can reuse it. You can reuse for years to come. Yeah, I see in the comment from Nick that the budgets are very tight. Yeah, that's why we really tried to make this something that could grow with you as well. We know that a PLC is an investment. The one good thing is the Opta is a fantastic price point for an educational kit, and then it has just a very, very low consumable of that wiring that might need to be replaced, and you would just need a couple of spools of that every year. You would need really three. You would need red, black, and white. To really have that same experience. Or you could save the jumpers and reuse them, but I would highly recommend replacing those with a new group of students so they can have that same experience. What other questions might we have about the Opta?
if I had a semester-long course, is there enough material to be able to fulfill that? And is there a list of a materials list that coincides with the example projects or extended projects that you showed?
Yes. Okay. Great question. So we say 20 hours of content, but that's if you sat down and went straight through everything all in one day. We know that's not going to happen in a typical class setting. And so definitely there is roughly a semester's worth of material in the course, depending on how you break it out. And yes, there is. If we go through, for example, every lesson has the materials list of what it needs. In most cases, the most of it is actually under getting started when we go to assemble the PLC starter kit. Where it's going to tell you that you need wiring the kits. For the wiring, you need some tools. You need a Phillips screwdriver and flat screwdrivers, wire cutting pliers, wire stripping pliers, and then that's pretty much it, what you need in addition to um, just the course content for this. So all of the DIN Simulate lessons, all the contents in the kit. And then if you wanted to do the extra projects, you would need either just two kits to use two Optas, and you would need some 24-volt DC motors. But we have all of that available in the courses. And you know what? That's actually, I'll make a suggestion too that we just create an overall materials list because I don't know that there is right off the top, but it's in the content under getting started.
Are there other sensors to use besides the temperature sensor?
Yeah, so the kit includes the temperature sensor and then it has the on-off switches. So those are the only ones in this particular kit, but you could integrate any third-party sensors that you might already have in your makerspace. The Opta's pretty flexible to working with anything that will work with an industrial PLC. You could also work with our Nikola line of sensors, so you could certainly add more sensors to it.
Do the wire come in spools to replace?
Yeah, so the wire comes in the kit, sort of already, cut to certain lengths or spooled up. But any industrial supply house would sell a spool of that wire, so you could get it from anywhere.
If I have limited knowledge, is there a way to get information to get past the problem?
If there's a way to get past a problem, like as far as
Yep.
is that a
Yep.
technical?
So like if a
Oh,
teacher doesn't have an extensive background, as they're facilitating, is there resources in there to help teachers facilitate?
there are resources for teachers. The other thing that I'll point out is that Arduino offers technical support for all of our educational kits. So if the Arduino docs didn't solve the problem, you could open up a support ticket on our website and we could actually connect you with one of our field applications engineers to try to help get you over that hump and answer the question. We actually have staff based here in the Americas that answer those support tickets, and it's pretty easy for us to set up a call. It might take us a couple of days to set that up for you, but we're happy to do that and do it all the time with faculty members.
Yeah, and is that something that you can kind of further expand on? Is any teacher resources that come um, with the program or resources for a facilitator?
Yep. That is going to be online in the course content. And so all of that information is there. It's built into the course. And then we have the video content as well that we link there. So there's not a different sort of like set of teacher notes because everything is sort of included into the content. But we can certainly link also to the Arduino docs piece of it as well. The docs is where I would point somebody that wanted extra resources about the Opta. And that would just be docs.arduino.com or .cc, excuse me.
Is there a discount for bulk purchases?
Yeah, so I mean, depending on the number and quantity, we can certainly work with Pitsco, and we can come up with whatever the value adds that you happen to need. We do make system level and district deals and classroom sets. It's kind of a common way that these are sold, and so yes, we're happy to have those conversations. You would start that process by contacting your Pitsco sales rep, and then we could work out whatever type of arrangement that we needed for a volume sale.
What type of jobs are the students going to go into? So if they're going through this course and they're learning these skills, could you give some examples of like different jobs or industries that this would tie back to?
Yeah, so it's all across the advanced manufacturing space is where typically these types of jobs would go into. And these are normally technician level jobs. So there's a wide array of folks that are technicians at various levels in industrial manufacturing plants. Anything from mechatronics to the sort of the new advanced manufacturing plants, we see the Opta used quite a bit in typical like furniture manufacturing, in HVAC environments, in compressor type pump and tank systems. So it's a wide array of factory technicians, but normally it's a technician level is where you would start with this training. And there's a wide array of job titles. Like sometimes they're called industrial systems engineers or mechatronics technicians, or sometimes they're referred to as PLC programmers. So there's a different array of job titles where they find out. Actually, one of our biggest customers, who I won't name because they probably wouldn't want us to this, actually started because the CEO's son had used Arduino in a school system and said, "Hey, Dad, check out this YouTube from this Mark Rober video from Arduino," and it made them start thinking they could use it in an industrial environment, and now they have $1 million plus business. And so it really just kind of pops up all over the place. Where you might find Opta use, but we're used a lot in condition monitoring type scenarios.
I was actually in a manufacturing facility that was implementing a lot of robotics and work cell type environments, and they had a ton of PLCs in place on a massive level. And we're talking industry level, like robotic arms that are moving pallets and wrapping pallets and moving things through assembly lines, metal tube, cutting metal tubes and making different fasteners. But I was blown away by how many times I heard the word PLC while we were getting the tour of the facility and all of the different technicians, and not necessarily just for one kind of application of what a robot was doing, but for so many different applications um, that were being used, and the number of those technicians that were in the factory. And they were just talking a lot about how they are increasing the automation in their factories and how that's going to play a part. So
Yeah. PLCs are really the workhorses of industrial automation. They're the equivalent to the Uno in all of these projects that educators have done for years and years with Arduino, but just taken to the industrial space. They really, their goal is to make it easy to start getting sort of sensor data and controlling things in a factory environment. It's just built in a format that's to industrial spec, working with 24 volts, and that is rated for a factory type of environment. So it's a much more hardened device than like a typical Uno would be, but it really is designed to kind of be that overall workhorse of the automation space.
a chance to ask one of the gentleman that was giving us the tour, like what skills do you see being like in the future, the most needed to help with these and computer science, coding, having that physical experience and understanding, to be able to work on the machines, maintenance, be able to work with the PLC troubleshoot. They really saw that that skill set was going to be something that was going to become more and more. So you're talking about how with this platform you can move between that ladder logic, which is the industry standard, but also more traditional coding of a similar device. And so they really see that as the next kind of skill set level to help those technicians or work in kind of a technician capacity.
Yeah, I think one thing that's going to be very interesting, right, is as things kind of progress, there are going to be these types of AI coding assistants. In fact, our cloud IDs is launching an AI coding assistant, but there'll still be this need for someone that can actually understand the physical components and how they connect together and how to, diagnose all of that. And that's one of the things I think this skill set or this kit helps to integrate is that physically having to connect the device and wire it and troubleshoot it is something that we impart in this skill set and having that overall kind of base of knowledge of, how do I connect this and understand how it works together.
So a couple questions. Is there any home projects the students could do?
Yeah, Kathy, this is small enough. It comes in a box where students could take it home if you're comfortable with that. Having them take it home, then yes, certainly. This kit fits in a small box and can travel. Not a problem at all. And then the content is all online, so you could certainly have students do it from whatever, workspace that you wanted them to work with. So yes, definitely. Not a problem at all. In fact, I have had some great conversation with educators that use the Opta for distance education courses in the university space.
Is this kit the only one, or is there an advanced kit as well?
So this is our student-facing kit that is basically for like teaching the wiring concepts. We do have a professional kit on the pro side of Arduino that covers the same concepts, but we assume you already know the electricity and the wiring. We don't teach those skill sets in that course. We just start basically with the programming because it's designed for someone that already knows PLCs and is just jumping into the Arduino PLC ecosystem for the first time. So in this sense, I think the PLC student kit is a little bit of a better experience for actual learners that have not used a PLC before because they're going to get a wider array of skills out of this particular course.
Will we be able to get a copy of this webinar? Yes. We will send everyone that registered for the webinar in the email a link to be able to watch the recording when it's available, which should be the first part of next week. I don't see any other questions.
Well, you'll have been a fantastic audience. It's been so much fun. What I will say is, as you're thinking about PLCs and how to integrate them into your lessons, if you have questions that pop up after the webinar, reach out to either your Pitsco sales team or myself. We're happy to have conversations or to bounce back and forth by email to help answer any questions that you might have and to help connect you with whatever resources you need to make industrial automation and this type of education for PLCs really applicable to your classroom. We're happy to help, even to troubleshoot and to come up with different ways to present the content, whatever you need to make it work for you. We're happy to do that.